Right. Welcome to our third presentation of the day. With us is Lovemore Chipindu, who take us through data science use cases in agriculture. Lovemore, you can take it away.
Thank you very much, Leonard. I hope my screen is very clear, and also maybe my voice projection as well. Okay, I really wanted to appreciate the way maybe you are marketing data science, especially in Zimbabwe, coming up with these kinds of conferences where we can sit down together, maybe as professionals, and share ideas. So I'm not going to give maybe a lot of background about myself, but let's go straight into the subject of today. So I'm going to share something specifically on data science and marketing intelligence use cases in agriculture. You know, my background in general is not agriculture, but I ended up in that field because of several reasons. And you discover that there are a lot of both untapped and tapped use cases in agriculture. Remember, when we are talking about agriculture, we are talking about crops. We are also talking about animals and so on and so on. So whatever I'm going to say is going to be biased towards the crop because we are more into crop research. So the agenda, I think the first part of my slides, I'm going to share something about the data science use cases in agriculture, and not about the wishes, not about whatever we desire to do in future, but what we have done so far and what also can be done. And remember, it's going to be just a summary because there is no way we can utilize maybe everything or this platform in terms of sharing whatever we are doing in the agricultural space because we have a lot. We have a lot. So we are going to, you are going to know something about crop yield prediction, phenotyping, agriculture technology adoption, diffusion, soil moisture prediction, and the last part is going to focus on marketing intelligence. Okay, so what are these data science use cases in agriculture? You realize that the aspect of finding soil type and features and also crop mapping is one of the major aspect that most of the people are specializing in, especially in the agricultural space. And you see that they're implementing a lot of machine learning techniques in terms of trying to do weather forecast and to keep the checks on crops health. You also realize that fertilizer suggestion through keen diagnosis is also one of the major aspects that most of the people are interested in, or most of the people are doing in the field of agriculture, utilizing these modern technologies. The suggestion of pesticides and detection of diseases. And these days, people are talking a lot about automated irrigation systems to minimize water use. But before maybe I say a lot about data science, especially in the Zimbabwean space, we have heard a lot about this data science, machine learning, artificial intelligence. But at the moment, I want to believe that we are just preaching about this machine learning, data science, and whatever gospel without the palpable or the real application to some extent. I think we have done a lot, yes, which is quite okay to talk about it, to conscientize industries and everyone who is interested about this. But in terms of the real application, I think we really need to move a step forward and begin to showcase what we are able to do or what we are currently do, because that's the only way of encouraging special industry. Remember, to hire a data scientist in Zimbabwe, most of the companies, they are not interested in that because they recognize it as an expense. As it is something which is very expensive, they don't recognize it as an important aspect, as an important component, which is part of the organization. Though we are saying decision making based on data analytics in any organization is very critical and is very important. So besides whatever I was talking about, especially about some of the applications of data science in the agricultural sector, so I'll just say something about how agriculture can benefit, especially from machine learning, because these days they are trying to promote what they call smart agriculture. So agriculture cannot be smart when we are not talking about machine learning technologies, or when we are not talking about big data and so on. It cannot be smart. We are talking about excellence in agronomy. We are talking about excellence in breeding. All those aspects requires some collaborative efforts, especially from those who are outside agriculture, because most of the people who are in the agricultural sector, some of them, they have the agricultural background, and to them to then begin talking about this machine learning or data science techniques is very difficult, which automatically means that we really need some other people with different backgrounds to really chip in and then come up and design useful tools, so that we then claim that we have smart agriculture. You become relevant. One thing that you really need to appreciate about agriculture is that it's something which is very practical. When we are working, remember agriculture, for example, in the case of Zimbabwe, agriculture is the backbone of our economy, and even the government is promoting conservation agriculture technologies. They are also trying to encourage farmers to adopt some mechanization equipment to transform how they are practicing their agriculture. So when you're dealing with smallholder farmers, there is no way you can go them and begin to boast talking about machine learning, AI, algorithms, those terminologies. It doesn't work. But the real the smallholder farmers, what they want to hear is, what's the best solution? Can I adopt this, or can I take this route, or can I ignore this aspect? What can I do when I have this and that problem? Right? I hope you are everyone will understand this aspect, because even if we publish some papers, we farmers indirectly benefit from the publications that we have. They are for academic purposes. But when we are talking about the real solutions, we are talking about something very much tangible that can directly help our farmers in the rural areas. So how agriculture can benefit from machine learnings and these data science technologies? We have the species management, where we have the species breeding or even the species recognition. Then the other aspect is about the field condition management, where you will be doing a lot of soil management and water management. So we also have another aspect focusing on we also have another aspect focusing on crop management, where you are able to do yield prediction, crop quality, disease detection, weed detection, and the livestock management, where you can focus on livestock production, animal welfare, farmers little helper, and so on and so on and so on. So in this case, we are saying the mechanism that drives smart farming is machine learning, which is the scientific field that gives machines the ability to learn without being strictly programmed. So you discover that in the field of agriculture, a lot of researches are being carried out. So we have a lot of data sets. And at the end of the day, after maybe writing some papers and after doing some analysis, we just dump that data set, and of which that data set to some extent can actually be used by some other people to develop some applications that can even help our farmers. So um, let me just say a little bit about the most popular and commonly used models in agriculture. When you search on internet, you discover that they are the artificial and deep neural networks, they are very much popular and they are being used in different ways. But in most cases, in terms of just publishing articles and so on and so on. So and also the support vector machines, especially in this case, the SVMs are uh, in most cases we say they are binary classifiers that construct a linear separating hyperplane to classify the data instances. So in the field of agriculture, they are being used maybe for classification, regression, and as well as clustering. So in farming, they are used to predict yield and quality of crops as well as livestock production. So in the next few minutes, I'm going to share some of the work that we did in terms of experimenting or in terms of evaluating how agriculture can actually benefit from data science, from machine learning, and all these other aspects that we are talking about. So we did we did one of the work which was focusing on evaluating machine learning algorithms for predicting maize yield under conservation agriculture, that is in Eastern and Southern Africa. So in this case, you see that in agriculture, yield is a very important aspect. And what contributes, we have a lot of variables that contribute to this aspect that we are saying yield. And when you are saying conservation agriculture, I think you realize that especially in Zimbabwe, we are talking about Fumvudza, smart way of farming. So I am not going to dive more into conservation agriculture, but I can just give you some examples like CA rotation, we are doing rotation, we are doing intercropping, and so on and so on. And we also have the conventional way of doing it. So in this case, we really want to see which system can the machine learning algorithms accurately predict the yield from all these different cropping systems. So in this case, what we then discovered is that yes, in fact we experimented with about 6 algorithms to see which one was far much better. Yes, the results were to some extent interesting, and they really suggest that there is need for improvement, whereby some of the models, of course, like the LDA, which is the linear discriminant analysis algorithms, yes, performed to some extent better, as well as the K nearest neighborhood. So this is one of the aspects which is more of yield prediction. It's not only about maize yield prediction, it's also about wheat or any prediction of any crop. So before I even jump into another aspect, you discover that we have a lot of biophysical models designed specifically for yield simulation and prediction, such as the decision support system for agrotechnologies, which is the DSAT. We also have APSIM and so on. But the challenge that we have with all those models, that they require a lot of data, the crop management data, weather data, and so on and so on and so on. So it's quite an interesting field whereby, or an interesting gap whereby someone can venture in and try to compare the two aspects and see, are the machine learning better, or else in the agricultural sector they are supposed to adopt these machine learning algorithms. But to some extent, because the models, these biophysical models, we have companies that develop them. So if you say you totally want to substitute them, you are not going to succeed, because obviously they are not going to accept that. Maybe if you present it as a complementary procedure, then it will work. So that's the other task that we are currently working on, to actually see how best we can complement the existing crop yield prediction models using this machine learning aspect. So the other procedure is about the phenotyping, which is more of some physical identification of some maybe characteristics of any agricultural whatever crop, and so on and so on. So in this case, it was more of analyzing the images. Remember, I was talking about yield prediction, which is very important. So to some extent, we really want to estimate or to calculate yield based on the maize kernels. But because of diseases and some other environmental conditions, you see that some of the maize cobs or some of the maize kernels, they have maybe abortion and so on. But you can physically count the maize cobs when they are maybe very much few. But when you are having 20,000, 80,000, 1 million cobs, you can't just do it by hand. So in this case, we're trying to see if it's possible to come up with some machine learning algorithms that can actually detect maize kernel absorption, so that we'll be able to estimate the yield based on whatever we want to achieve. Because we have a lot of technologies in the field of phenotyping. Because the moment you train something and it proves to work, then it will be very easy to incorporate that or to implement that in any existing phenotyping technologies, be it some gadgets that we now have, cameras and so on. Because in the background, what will be working is this machine learning algorithm. So in this work, what I mean by abortion, like in this case, there are two images that you are seeing here. The first picture, it shows a proper maize cob without abortion, and the ears are very much clear. And we also have another picture below, which is showing some ears with adoption, with abortion. So in this case, we're using some binary machine learning algorithms and deep convolutional neural networks. So what exactly? So all the tested binary machine learning algorithms performed very well in detecting and classifying abortion, but the support vector machine and the LR, the SVM and the LR were far much better than any other tested methods. So in evaluating the used methods at different cross-validation intervals, the SVM and LR were most stable and reliable, as they maintained the 100% level of accuracy compared to the other machine learning algorithms. So in this case, like the other picture that you are seeing, you can see that that one is a confusion matrix, which is also an evaluation technique in terms of seeing how these algorithms are really performing. So we recommended that the SVM and LR are better machine learning algorithm in terms of detecting the abortion in maize kernels. So then let me just maybe dive into the other aspect, which is quite different. So you discover that in the agricultural space, we try to promote different technologies, and we expect farmers to adopt those technologies. So what we can say, technology diffusion. So a lot of investments or a lot of efforts have been made in terms of promoting different technologies in the agriculture. But the question is, can we really come up with the proper techniques, time series techniques that can trace this diffusion of agricultural technology adoption over time? Or else we just assume that everything is okay. So this is the other work that we have done. So in this case, we were tracing different technologies and different investments that were made, especially during different time intervals, and try to see what happened during that time and what are the possibility of scaling up the adoption of these technologies. So in this case, we implemented some unsupervised regime shifting detection techniques, like the unsupervised machine learning time series techniques, such as like the hidden Markov model regression. So besides the commonly used ARIMA models, we also experimented the Prophet model. So what we're trying to do, or what we're trying to achieve, sometimes in the donor world, they believe that if you provide a concrete evidence of what is really transpiring on the ground, you can easily get some funding. So because if USA, for example, is giving you a lot of money to do a lot of researches, at the end of the day, the they want to see the progress. They can't continue giving you money this year, money second year, and they don't trace the progress, and they want to be advised what next, what is really transpiring, what happened during this year when we started to promote maybe mechanization in Zimbabwe, or conservation agriculture in terms of Vumvudza, which is being supported by the government. So we experimented this using the time series data that we gathered when we were doing some of the surveys, like what we were seeing. It was mainly focusing on 3 countries, that is Zimbabwe, Zambia, and Malawi. So so in this case, so this the HMR and the ARIMA, what we're trying to do is to estimate or predict different intervals or different clusters, and then trace which year happened, and then from the literature will then help us to actually say, okay, in terms of the minimum tillage, it was more prevalent maybe in cluster number 3, which is 1990 to 1995. Which was 1990 to 1995. Okay, 1990 to 1995, what happened? What were the projects? Which project were really active in terms of promoting conservation agriculture or any other technology in agriculture? Then it becomes very easy. Then we'll be able to map some of the scaling technology. What can we do for us to really improve this, or to scale up this in terms of investment and so on? I think you realize that one of the major challenge that smallholder farmers usually face is a lack of funding, because they cannot secure loans from banks. Why? Because they don't have collateral security. So we then want to reach a point where we can encourage banks to give loans to these smallholder farmers based on the type of cropping systems that they are going to use. If we have a lot of researches which have proved that maybe conservation agriculture is performing very well, it automatically means that if we invest, if we can give some farmers based on the type of system they want to implement, then to some extent they will be able to pay back the monies. So instead of focusing on those companies or some individuals which have maybe some collateral security, we really need to just shift and try to promote them in that way. So we managed to come up with the different clusters. We also, and these clusters helped us even to dig deep into the identification of different projects which were done during different periods, and try to map some of the initiatives that can help to scale up anyway. So besides some of those aspects like yield prediction, phenotyping, and so on, we did another work which was focusing on soil moisture prediction, which is very important in agriculture, because any type of soil, be it sand or clay, you really need to know the moisture content or the water holding capacity of any soil, so that even any cropping system that you are going to practice on that soil, maybe you'll be assured that at least you are going to get maybe better yield. So we experimented again with different machine learning algorithms, and for sure they were performing very well, as you can see from based on accuracy or some the other evaluation the metric, which is the kappa statistics. You can see that these models, they were performing very well in terms of water prediction, which is really helpful to a farmer. But when we are going to a smallholder farmer, we are not presenting these algorithms, but you are giving them the recommendation and say this kind of depth, especially when you have sandy soils, can actually help you. This is supposed to be, if you are doing maybe some conservation agriculture and you are digging those holes, you are also able to recommend the depth of those holes. Whether you use the machine learning algorithm is another story, especially to a farmer. So besides so in this case, I gave you some of the work that we are currently doing in terms of the use cases and so on and so on. So the next in the next slide, we are going to talk a lot about the marketing intelligence. Remember, I already alluded to the fact that the development maybe of agriculture or smart farming requires some collaborative effort. We need the IT guys, we need the researchers, we need the breeders, crop breeders, and so on and so on. So in this case, I'm going to focus on a particular, specific example, which is more of like the breeding process, be it crop plant breeding aspect. So in the other research that was which is currently ongoing, or which was implemented some years ago, like in Ethiopia, Kenya, Tanzania, and Uganda. We were trying to evaluate and see if the farmers are really adopting the new varieties that are being promoted by different organizations, because we want them to use hybrid varieties and also the other improved varieties which are resistant to diseases, which are high yielding, which needs maybe very little fertilizer requirements, and so on, different traits that we are interested in. But you discover that it's very difficult to encourage a farmer. Why? Because they are used to their local varieties for different reasons. But what we then identified is that we have a very big problem in terms of communicating with the smallholder farmers. Because if you are a scientist, if you are a plant breeder for sure, and you really want to encourage the farmers, you are supposed to communicate in the language, using the language that they understand. So there are supposed to be some kind of a mutual understanding. But those who are doing the breeding process, they are not the ones who are marketing the seeds or these varieties, the maize varieties that we are talking about. And we have the seed dealers, but these seed dealers, they are not breeders. At the same time, the smallholder farmers, they don't understand some of the languages that that we use. And imagine a lot of investments are being made in terms towards the development of these new hybrid varieties, but the adoption remains stubbornly low, which is quite worrisome. So the question is, what is supposed to be done to improve the willingness of farmers to adopt multiple maize varieties? So at the end of the day, we want to encourage them to adopt multiple varieties, so that at the end of the day, they'll be able to evaluate they will be able to evaluate and see which varieties are performing far much better, so that they will be able to then say, okay, for whatever I'm doing, if I plant this maize variety, obviously I'm going to get a lot of, I'm going to get maybe a significant yield. So as you can see in these two plots, the first one is indicating some of the gaps that we can identify in terms of integrating the plant breeders, those who are doing seed marketing, and the smallholder farmers. Remember, as a maize breeder, when you're doing the researches, you can't work alone, but you really need those who are going to market the seeds. But what we are targeting are the smallholder farmers. But the question is, do the seed marketers really understand the preferences of smallholder farmers? Because the reason why we are emphasizing on smallholder farmers, they are the majority, because they don't have enough resources to practice whatever they want to practice. They're totally different from commercial farmers. So the question is, are the smallholder farmers really, are the seed marketers really understand the preferences of smallholder farmers? Because their preferences are very dynamic, and we really need to understand that. Then the other question is, are the plant breeders or agricultural researchers really understand, are they really knowledgeable about the preferences of these smallholder farmers? So these are the gaps that you can identify. So how best can we close these gaps? We then need some intelligence in terms of how we market our agricultural produce or our agricultural products, right? So as you can see, most of the farmers, they are willing to just use maybe single varieties and these single varieties, they are, in most cases, they are local varieties, and they don't want, very few are willing to adopt multiple varieties, because in terms of understanding each other, that is the farmers, those who are doing marketing, and also the plant breeders, they don't understand each other. So what exactly are we trying to do? So in this case, we want a smart way of recommending farmers to adopt hybrid varieties. So what we are saying is farmers are seeking to adopt maize hybrid variety, but what determines their preference behavior given more than one variety are the traits characteristics of the varieties. So in this case we are collaborating with the IT guys, those who are more into application development, because what we have the data set, we can build the algorithms, because what we can build those algorithms, but even if we build them and publish a paper, it's not going to benefit anyone. But if we develop some kind of, we can integrate everything and develop an application so that when the farmer comes to in this case, what you're doing is more of product profiling. You have your product, you have a variety, you have the characteristics of the variety, yes, in the database, right? So when the farmer comes and gives and then being asked about his or her preferences, that farmer is going to describe everything. Then what is the seed dealer supposed to do? Is then supposed to, okay, you are saying you are interested in a variety which can give you maybe a significant yield, resistant to disease, tolerance to this and that. Okay, the seed dealer can then just punch in the computer. Then in the background, there is machine learning, whatever, which will be running, and then then the recommendations, then the system will then retrieve a combination of maybe the best variety, the top 3 varieties, or any range of varieties that you can recommend to that farmer. Right. So in this case, it means that we now have the breeder, we now have those who are doing the marketing, and we now have the farmer in the same place, utilizing this platform or these technologies. So this is how the farmers or the agricultural sector can actually benefit in terms of marketing intelligence, especially after implementing some of these machine learning techniques. So one of the aspects that we experimented with, like in terms of marketing intelligence, there's this approach which is commonly used in some mega markets and so on, especially in developed countries, what we call or what they call the market basket analysis. And the commonly used algorithm is the a priori, what they call the a priori algorithm. So if you go to the developed countries, sometimes when they want to determine their stock or a combination of products which can supplement or which can complement each other, they analyze the basket of each and every customer or the basket of each and every consumer to some extent. So if you see that in each and every basket, most people, maybe most of the customer, they are buying sugar, milk, and cooking oil. To some extent, these products, when you are having one product, you really need the other one, because in most cases, most of the customers, they buy a combination of those products. So in terms of restocking, it helps a lot. All right. So what were we trying to do? So we viewed it in that aspect of some mega markets and so on. Then we said, okay, we have different range of varieties with different trait characteristics, but we want to recommend these hybrid varieties to a farmer. But we have this question: which varieties are liked and adopted because of the same reasons by the farmers? Then we have a range of varieties, reasons for variety preference. Some of the reasons are agronomic, some of the reasons are the marketing aspect, the grain traits. We have the plant architectural reasons. We have the aspect of stress tolerance, and also the consumption traits. So if you have maybe a basket of varieties which are being liked for the same reasons, it automatically means that those varieties can substitute or complement each other. Okay, if they can substitute each other, which means you now have the foundation of the platform to recommend multiple varieties to your smallholder farmers, right? Which is now there is an aspect of some a better way, or a better way of encouraging farmers to adopt these products. So what we are saying is, in this market basket analysis algorithm, will enhance maybe to extract, because it's more like a data mining technique, to extract a combination of varieties that can be that is the same traits. So if sometimes it's because of farmers don't know. the reasons why they prefer one variety, you discover is the same reasons why we have another hybrid variety. So which makes it then easy for us to recommend multiple varieties. So at the end of the day, we want these seed dealers to have this kind of knowledge so that their life can be easy when they are being approached by these farmers, so that we don't end up investing a lot of resources in breeding, while least the adoption remains worrisome. So so in terms of this marketing aspect, I think this is much of the work that and there is a lot. It's not only about varieties, but it's also about maybe different technologies that we have, different maybe if you want to to recommend different herbicides, different techniques of farming, and so on and so on. It's not only limited to to these mega markets or to this uh, maize hybrid seeds recommendations, but we have a lot that we can learn, or we have a lot that we can extract from the application of these approaches. Then maybe as concluding remarks. So these days we are talking about excellence in breeding, excellence in agronomy, and so on and so on. So there is no way we can talk about precision agriculture without a proper implementation of these data science, ML, or artificial intelligent technologies. We really need to collaborate and come up with the different technologies that we can have. As I already highlighted that it's supposed to be more of a collaborative effort, because I don't believe that we have what we call a complete data scientist, because this one, being a data scientist or data science, is an umbrella term which involves a lot of aspects. So you can't be everything. You are very strong in another area, but you are weak in another area. So we really need to complement each other. We really need the guys coming from computer science, coming from different fields. We integrate and we come together and come up with the reasonable technologies. So the major reason why you see maybe in some of our African countries this aspect of technology remains a dream, and we remain at the theory level of this technology, is because we are interested, or we boast about these interesting terminologies and so on, but our focus is not interested in the real or the palpable real application of these technologies. Why? Because we don't have this spirit of being collaborative. So we really need to work together for us to achieve a lot. So the as for me, my background is not agriculture. I did a lot of my background is applied statistics, but later on did data science and AI. Fair and fine. But why is it that I'm in the agricultural space? It's because it's really interesting, and it's very much practical, and it will force you to be very much practical. So, but you can only be practical when you collaborate with the people who are already in the field. If I want to understand a lot about genetics, if I want to build any genetic algorithm, I really need to interact with those who are doing breeding, so that we'll be able to develop something which is very much beneficial, right? So if I really want to understand about maybe phenotyping, about plant physiology, I really need to to work with the plant physiologist, so that we come up with some collaborative ideas and we'll be able to implement something. So without that proper understanding, you will never able to do something. Those in the agricultural space, they understand their language, they understand their things. But to some extent, they don't understand some of these technologies that we are talking about. That's why we are saying collaboration, and collaboration is needed. So if you really want to enjoy yourself, I worked in a lot of spaces, be it in the health sector, um, in the finance sector, doing a lot of financial engineering. But one field that is very much interesting to me is the agricultural sector. Why? Because the application of this technology is something else. We have a lot to do. We have a lot to do. We have a lot to achieve. I think that's the end of this presentation. Thank you very much, Data Science Zimbabwe.
Thank you very much, Lovemore, for quite an insightful presentation and for the suggestions that you have made to the community as well in terms of collaborations. It is certainly something that we are hoping we'll see a lot of post this conference and into the future. We know people have always spoken about how agriculture is important to the Zimbabwean industry, and smart agriculture, precision agriculture is definitely going to play a key role in ensuring that we remain food secure. Okay, if there are any questions, maybe we'll just wait for a few minutes to see if there are any questions or any comments.
Okay.
Yeah, so there is a question from Dananai there. You can address it.
The question, what is the question? The question is saying, I didn't get the question.
Okay, it's saying, which approach can we adopt in getting data sets from rural areas, considering the backwardness of rural farmers in terms of technology?
In terms of technology. Thank you very much. It's quite an interesting question. But already we have a lot of organization which are doing a lot of researches in rural areas. For example, like the International Maize and Wheat Improvement Center, we're doing a lot of agricultural researches working with farmers who are in the rural areas. That's why I said collaboration is very important. So, which means if you really want real data from those rural areas, you can't just go. You really need to work with some of the organizations who are doing a lot of researches there. Because to some extent, if you just approach them, obviously you are not going to get anything. Yes, they are backward, but it doesn't mean that we cannot get anything meaningful from them. But the approach is to work together with the organizations which are already doing some researches there. I think it's quite interesting that even if you come up with some of the ideas, working with some of the organizations like CIMIT, you discover that maybe it can be something that can be transformed to another level and source some funding so that it can be done as some kind of a research. Farmers sometimes they don't just release their information. If you want something from farmers, especially for free, and they realize that they are not going to benefit anything from whatever you are doing, they are not going to release anything. So the approach is to then consult those who are already doing the work and say, if I want this kind of information, how best can I get it? What kind of a project related to whatever I want that you are doing in these rural areas? How best can we then have this data set? And another thing maybe that I can highlight is that the other issue that we have, like in this organization, that we don't have maybe some kind of what we can refer to as a time series data, which can really helps you to trace this, because some of the data set will be project based. You do a project for 3 years and everything, and when everything ends, then that's the end of everything. When then if you want to do some kind of a 10-year, 12-year, or 50-year or 13-year assessment, it's no longer possible. So what I can only say to you is that collaboration is very important. Work with the organization which are already doing the work in rural areas. You discover that it becomes very easy. Don't isolate yourself and try to make sure that, and try to gather that information from. It will be very difficult, expensive at the same time, and you end up saying it's very difficult. You can't get the information from the rural areas.
Thank you again, Lovemore. That's a very powerful response. Again, highlighting the need for collaboration. And we certainly hope that the people who are tuning in their projects, they will definitely take to heart what you have said about not having to work, in silos or in isolation, and try and find out how they can build networks, and which organizations they can also be or help, add value to, or with respect to what they are doing. And yeah, so thank you once again for that. So we also have some comments with regards to your presentation. Great presentation from Dondirai, very clever stuff. I'm sure Ian was referring to when you're talking to about the models. And the demonstration of the link between the technologies and the subject matter application area is a breath of fresh air, not only buzzwords, but well shown to be applicable. That's a great comment there. Nicely arranged presentation with practical use cases and examples of what you have done. So,
yeah, it's very important. Maybe if I can highlight something in relation to the other comment that you read. It's a very powerful comment. Sometimes in most cases, I'm involved in a lot of maybe projects to do with machine learning and so on. So like the hackathon challenges and so on. So when you're an adjudicator, you discover that someone is writing an interesting proposal, but that proposal is more like someone just going maybe on internet, retrieve the information, and that person is writing about some interesting way about artificial intelligence, machine learning, automated whatever and whatever. But when you then evaluate it on the basis of the practical basis, realize that is just a heap of words, and the practical element, you can't even sense that practical part out of that work. I think it's a high time as Africans to some extent, or as Zimbabweans or whatever, uh, it's a high time we really sit down and say, guys, we are done with the theoretical preaching of this concept of data science and artificial intelligence. Let's just shift it to another level. Again, we have a problem with our universities to some extent, because in sometimes you evaluate some of the stuff that we learn from our universities. Then you say, okay, in this fourth industrial revolution, what's the relevance? Are they able to produce someone who is going to be very much competitive or very much practical in terms of this field? Right now, if you want maybe any job from outside Africa, especially in the field of data science, I think they will force you to attend 4, 5, 6, 7 interviews as a way of verifying if you are really able to do it. Why? Because they doubt even our institutions in terms of this. Because we are very good in terms of encouraging people, but in terms of the practical aspect. So in most cases, it's good also to encourage the institutions, our educational institutions, the companies, and so on and so on and so on, so that we become relevant in a certain way and begin to implement some of these aspects that we always dream about, that we always discuss about, that we always try to talk about and boast about in terms of how good they are, but the practical element sometimes lacks. So I really appreciate that aspect, that we always talk about the theory of it, but lacking the practical element. Thank you. Thank you.
all right. Thank you very much, Lovemore. Thank you very much for the presentation, and for coming through. We hope people who are more interested in the ideas that you shared will be able to reach out to you, and I'm sure via LinkedIn, if that's all right, to have a chat, or any other organizations who are interested in the intersection of agriculture, machine learning, artificial intelligence, data science. Thank you very much once again.
Thank you, Leonard. Really appreciate. Please.
All right. So thank you very much for tuning in to that particular session. We'll take another 10-minute break and we'll get into the last session of the day, which is on business and data. See you in the next session.